Hey, Vanessa. So the metric system is pretty easy. Distance is measured in meters. Weight is measured in grams. And volume, and that usually we're talking about liquid with volume, is measured in liters. But they're all measured the same way. Meters, grams, and liters are the base unit for each one of those things. When I look at those, so meters, liters, and grams are in the middle. And then we can go up or down from those. So let's say we have 1 meter or 1 liter or 1 gram. If I have a decimeter or a deciliter or a decigram, I have 0.1 of a meter, liter, or a gram. If I have a centimeter, liter, or gram, I have 0.01 of a meter, liter, or a gram. And if I have a milliliter, millimeter, or milligram, I have 0.001 of a meter, a liter, or a gram. So that's getting smaller. I can go up too. If I have a decagram or a decaliter or a decameter, I have 10 meter, liters, or grams. If I have a hectometer, liter, or gram, I have 100 meter, liters, or grams. And if I have a kilometer or a kiloliter or a kilogram, I have 1,000 meters, liters, or grams. So I could also say a decigram is 1/10 of a gram, a centimeter is 1/100th of a meter, a milliliter is 1/1000th of a milliliter. So they all work the same way. This is the base measure. Meters are the base measure, liters are a base measure, grams are a base measure, and then I can go up or I can go down. So when I look at these, if I'm going from small to large, all that I'm doing at each step is multiplying by 10. Oh no, I totally lied there. No, I'm not. Don't listen to me. I'm making shit up. Okay, no, we're not ready to talk about that yet. Hold on a second. So how do we use these measures? So let's go to the next page. I think everything goes in the same, there's kilo, hecta, deca, meters, liters, grams, and then we have deci, centi, and milli. Okay. Sometimes we need to go back and forth between them because we have, let's say we're measuring stuff and I'm adding up meters. Like I'm measuring my house for baseboards and I measure my house for baseboards and I add them all up and I end up getting, I don't know, let's say I'm measuring it in centimeters and I end up with 20,321 centimeters. Because the thing I'm measuring with is a little tiny ruler. So that's centimeters. Well, that's really weird. If I go to the hardware store and say, I want 20,321 centimeters of baseboards, they're going to look at me and say, yeah, you're cracked, woman. Like, no. So I'm going to think to myself and say, it'd be a lot more sense if I converted that to meters. Well, meters are here. How do I get from here to here? From centimeters to meters. I went up 1 and up 1. For each space I go up, I'm going to divide by 10. So if I have 20,321, and I'm going to divide it by 10 and divide it by 10, that's equal to 203.21 meters. Okay, or you can see what happened for every step I moved up, I moved my decimal. Because that's what dividing by 10 does. It moves the decimal to the left. So let's say I was a scientist again and I ended up with 335,292.3 milligrams of something. I don't know, I'm measuring water in a tank, or measuring, I don't know, Smarties, something. Well, okay, that's a pretty big number. So normally we wouldn't use big numbers like in science. We want them to be smaller. So this is milligrams. Here's milligrams. And let's say I want to convert that to kilograms. Okay, well, I want to convert that to kilograms. Well, kilograms, kilo is way up here. So how did I get from milligram to kilogram? I went up 1, 2, 3, 4, 5, 6 spaces. So I'm going to divide this by 10 6 times. Or I'm going to take that decimal and move it 6 places to the left. 1, 2, 3, 4, 5, 6. So 335,292.3 milligrams is 0.3352923 kilograms, or let's say 0.34 kilograms. 0.34 kilograms is a much more sensible way of talking about a measurement than 335,000 milligrams. So this is what we use conversions for. When we go from the small end and we're converting it to something bigger, we divide by 10. For each step, we have to go up to get there. So if I'm going from small to large, I divide by 10 for each step, which means, or if I go back here, if I have 335,292.3 milligrams, that's dumb. It makes a lot more sense as a scientist to talk about 0.34 kilograms. Okay, we're going to talk about this in person, but that's basically how metric works. I've got a base unit, grams, liters, or meters, and then everything that kilometer, hectometer, decimeter, centiliter, milliliter, it works the same. You start from the base unit and you either go up to 1,000 of them or you go down to 1/1000th of them. Okay, let's say we're going the other way. So we're going to go kilo, hecto, deca, milli, meters, liters, and grams, deci, centi, milli. Okay, so what if we were going the other way? So let's say I had, I don't know, 0.0056 kilograms. Okay, that's kind of a weird number. Maybe talking about that as kilograms is not a good way, and so I want to change it to grams instead. So I say, okay, where am I? I'm starting at kilo, so kilo is up here, and I want to go to grams, so grams is the base measurement there in the middle. So I'm going to go down 1, 2, 3 spaces. So now we're going down. So the last time when we were going up from small to big, we divided by 10. Now we're going from big to small, so we multiply by 10. Okay, so I'm going to take 0.056 times 10 times 10 times 10, which is equal to 5.6 grams. So 0.0056 kilograms is 5.6 grams. Or I can see what actually happened there. Every time I multiplied by 10, I moved my decimal 1 place to the right. Dividing moves your decimal left. Multiplying moves it to the right. Okay, so let's say I had 0.00051 hectometers. Okay, again, this is a silly measurement, 000 blah, 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 hectometers. That's weird. That's a pretty small number, so I want to change that to millimeters. So here's hectometers, because that's the H for hectometers, and here's milli, so that's where millimeters would be. So I have to go from hecta, and I have to go 1, 2, 3, 4, 5. So I'm going to multiply that by 10 by 5 times. 2, 3, 4, 5. So I'm going to get 5.1 millimeters. So 0.00051 hectometers is 5.1 millimeters. Or, again, I can see what that did is multiplying by 10 5 times, just move the decimal 1, 2, 3, 4, 5 times. So 5.1 millimeters is tiny, 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 tiny. So a centimeter is about the width of your finger. A millimeter is 1/10 of a centimeter. So this is like half a centimeter. So it doesn't make sense to be talking about this measurement as a hectometer, which is pretty big. It makes a lot more sense to talk about it as millimeters. So that's why we convert between different sizes of measurements in metric. It's just because if you have a really huge number, it makes sense to make it smaller. If I have a really tiny number, it makes sense to make it bigger. We just want numbers to make sense. So a scientist would much rather talk about 5.1 millimeters, which is a tiny measurement. It's half the width of your finger. It makes way more sense than talking about 0.0000051 hectometers, which is just